I am Professor Charlie Collins, and this is your daily dose of statistics. Today we are going to be going over some descriptive statistics, and more specifically some basic descriptive statistics. So we have your stat Sherpa here who is going to help us climb up this mountain. So he's down here at the base with us, and he'll keep coming along with us. So today we're going to be talking about percentages, ratios, and rates, tables, charts, and graphs. Now, basically what we're doing today is we're identifying ways in which to organize and present some basic data. And what I mean by basic is some univariate data. I don't mean basic in terms of this is easy to collect, or it's easy to analyze, or any of this is actually extremely easy to do. Basic I mean is sort of univariate descriptive statistics. So we'll go through today and describe ways to present raw data, or take raw data and present it in a way that makes sense and is readable to people outside of statistics. So our learning objectives for today is to understand the purpose of descriptive statistics, construct frequency tables, compute and interpret percentages, proportions, ratios, rates, and percentage change, and what each of those mean, and construct and analyze visual representations, such as histograms and pie charts. So let's start with frequency tables. Frequency tables, or frequency distributions, are tables that report frequencies in each response category of a particular variable. And so this can become confusing to people because oftentimes students want to create tables based on scores, and they are based on scores, but this is the frequency of each of those scores, right? If that makes sense. So if, for example, 1 equals yes and 0 equals no, it's the frequency of people who had 1s and frequency of the number of people who had 0s. So what this does is it organizes raw data into something more readable. And what raw data is if you have ever taken a survey, and say there's 10 questions on the survey, and I'm sure most of you have, the raw data is what is output to the statistician in the first sort of run, right? It's put out in a raw form. So it gives case by case every single individual's answer. And what we need to do as statisticians, and I'll show you a raw data table here in a second, what we need to do as statisticians is take that information and organize it in a way so that we can analyze it and organize it in a way where it's readable and presentable to an audience. Frequency distributions are primarily used for nominal and ordinal data, although not necessarily the case, but most often nominal and ordinal data. And what they do is report the frequencies of cases in each category, right? Remember, nominal and ordinal data are split up by different categories, and so the frequencies report the number of cases in these categories. And what we can do with frequency tables is we can use those to calculate things like percentages, proportions, ratios, so on and so forth. So let's take an example. Let's just say we have a prison rehabilitation program, and we're interested in the recidivism among the people who participate in the program. And just for those of you who aren't in the area, or in this field or area, recidivism is when people go back to prison, right? They recidivate. It's re-entry into prison after being released. So we have 4 variables here. We have whether or not the person recidivated, so the recidivism, yes or no. The sex of the person, female or male. Program participation, yes or no. And time in prison by months. Right, so each of these are nominal data with the exception of the last one, time in prison by months, which is an interval ratio variable. And so this is your raw data table, right? So each person has responded, quote unquote, to this survey or whatever it is, however we collected this data. So person 1 recidivated, case ID 1A is somebody who recidivated. Person A is a male. Person A participated in the program, and person A spent 10 months in prison. Person B did not recidivate, is a female, participated in the program and spent 100 months in prison. So this is what I mean by a raw data table. Now if I were to ask you something like, give me the percentage of people who are female, it would be difficult for you to do with this. You could do it fairly quickly with 10 cases. But imagine if you had 1,000 cases, or imagine if you had 1,500 cases, or even 100 cases. It would be much more difficult to do that, right? This is a much smaller data set than statisticians typically work with. And so what we can do is we can take this raw data and turn it into frequency tables. And this will help us describe the data in a much better way. Not necessarily a better way, but a way that's more readable to ourselves and to other people. So what we can do, and we'll focus on the first 3 variables here: recidivate, sex, and program participation. So what we can do is we can take that information and we could create frequency tables for it. So at the top here you see that we have a frequency table for the variable recidivism, where whether or not the person recidivated is on the left. So those are the 2 categories, no or yes. And then the frequency. So we can see that 6 people did not recidivate and 4 people recidivated. Frequency table for sex, we can see that 2 people are female and 8 people are male. And this number 1 and 2 here on the left, next to female and male, are the numerical representations of female and male, right? And we'll get more into that when we start building databases. That's important for building databases, because databases accept numerical information and they have a hard time with qualitative information or text information. So those numerical representations help us organize that data within a database. And then finally we have program participation. So we see that 3 people participated in the program, 7 people participated in the program and 3 people did not. Right, so this is your standard frequency table. So all we do is basically make counts of each of those categories, and that's the frequency, the number of people who were in each of those categories. So what we can do with frequency tables is we can take them and we can start calculating things like percentages and proportions, right? And you can sort of have an idea of how we do that, but we'll walk through that more specifically here. So what percentages and proportions do is they make sense of data. So if I were to tell you this sentence here, of the 345 prisoners who took part in the prison rehabilitation program, 256 did not recidivate within 5 years of completing the program. You can have a vague sense of how successful the program was, but it doesn't give you a necessary clear idea. So what percentages do is they standardize this data into the base of 100. So standardize it into percentages, right? We all know percentages as up to 100. You can't have more than 100%, right? As they typically say. So if we take the same information and we restructure it into a percentage, it would read like this. About 74% of the prisoners who took part in the prison rehabilitation program did not recidivate within 5 years of completing the program. Right? It's the same information, but now the data is organized in a way that's more readable, that's easier to interpret for somebody who doesn't do this work. And the formula is the percentage formula, right? And this should be fairly common to most of us. And the formula is the frequency divided by the n, which is the number of cases in all categories, or what we often call the sample size, times 100. So if we take our information here and we plug it in, we can see that the percentage of this, right, if we take 256, divide that by 345, which is the number of prisoners in the program, 256 is the number who did not recidivate, we times that by 100, and what we get is 74.2. So again, we can take this information and turn it into something that is more readable. So let's do this for our little frequency table here. So let's just look at our sample and the number of people who did not recidivate, right? So again, we take the frequency, divide that by the number of people, or the total N. And I've highlighted, I've color-coded each of these to try to make more sense of this so you can plug the numbers in. So if you fall behind a little bit, go back and try color-coding those numbers, and it should help you out a little bit. So we have no, which is the frequency of 6 divided by the total of 10 times 100 equals 60%, right? So what we find here is, in our little example, 60% of our little sample did not recidivate. Proportions are nearly identical to percentages. The only difference is it standardizes data into a base of 1 instead of 100. So we don't times proportions by 100, we just leave it with the first little equation there. And so instead of 60%, we have 0.6, right? So our proportion is 0.6. Now this is often, we'll be using proportions more as we move forward. We'll use proportions when we're looking at percentiles, for example, when we're getting into percentiles, when we're getting into the normal distribution, this is when we're going to be using proportions. So this is not necessarily as readable to your average audience, but it's used more than a percentage will be used for statisticians and for more complex statistical cases. So now we've covered percentages and proportions. Let's move into ratios, rates, and percentage change. Now, what ratios, rates, and percentage changes are they're just additional procedures to summarize your data. And there are different ways to summarize the data for different purposes, right? So it's important to understand the purpose when you're summarizing your data. So ratios basically are comparing relative different sizes and categories, or relative frequencies in two different categories. So we're comparing, for example, the number of people who recidivated versus the number who did not. Or if we're looking at rates, for example, the number of white people in a neighborhood versus the number of Asian people, for example. Right? So it tells us the ratio or proportion of two different groups in a sample. Rates, on the other hand, compare sizes of cases in one category to the entire population. Right? So while ratios are comparing two categories, the rates are comparing one category to the entire sample, right? So we hear rates all the time. When you're hearing about, for example, the Ebola breakout, the number of incidences of people who had gotten Ebola compared to the entire population is a rate, right? We hear of homicide rates, we hear of crime rates. All of these are the number of crimes or the number of homicides compared to the entire population of a city. And then we have percent change. And this is simply how much a variable has increased or decreased over time, right? So and this is a fairly simple example, but have I gained weight over the past year or have I lost weight? And at what percentage, right? So it has my baseline of now versus what my weight is in the future, and it compares those two numbers. So here's our formula for these. For ratio, it's the frequency of the number of people in the first category divided by the frequency of the number of people in the second category. For rates, it's the actual number of occurrences divided by the possible number of occurrences. And then for percent change, we have the frequency of the number of people in the second category, minus the number of people in the first category, divided by the number of people in the first category times 100. So I'll give you a second to write this down. And I just noticed there's a real small typo here, just to note. F2 should be the frequency the frequency or number of cases in the second category, not the first category. Okay, so let's move forward and let's do an example. So let's look at ratios. And so say we're interested in the relative size of recidivators versus non-recidivators in time 1. And again, these are color-coded. The numbers here are color-coded, so you can see where the numbers come from. That way you can go back and make sense of this if you need to. So what we're looking at is the frequency of people who did not recidivate in time 1 versus people who did recidivate in time 1. As we can see, we have 129 recidivators and non-recidivators in time 1 and 271 recidivators in time 1. We divide that and then we times that by 100. And timesing this by 100, what it does is it gives it a more standard, it standardizes it a little more, so it's slightly more interpretable, right? And so what we find here is that our number is 47.6. And so what does this mean? And what it means is that there are 47.6 non-recidivators for every 100 recidivators, right? Or we can switch that around and say for every 100 recidivators, there are 47.6 non-recidivators. And this is why we add that 100, because it makes more sense to say 47.6 non-recidivators for every 100 recidivators as opposed to saying 0.476 non-recidivators for every one recidivator, right? It just kind of standardizes it more into whole numbers. So let's take a look at rates. And so say we're interested in the recidivism rate for prisoners in time 1, right? So we have people who recidivated in time 1 divided by the total number of people who recidivated in time 1. Or, the total number of people in the program in time 1, right? So we have 271 divided by 400, which equals 0.6775. And what we can do is we can times this by 1,000. And I'm timesing this by 1,000 to think of a larger population, right? Maybe there's hundreds of people who go into this prison rehabilitation program on a yearly basis. And so this will standardize it more for that population. If we're doing something like a city, for example, we might want to times it by like 100,000 or maybe even 1 million, depending on how large the city or maybe the country is. So we do this based on the population you're working with, that you're trying to maybe generalize to. And so what we have here after we times this by 1,000 is 677.5. And so what is this telling us? This is telling us that there are 677.5 recidivators for every 1,000 people who go through the program, right? So for every 1,000 people that come through this program, 677.5 of them are likely to recidivate, right? So in a general sense, if this were a real program, this is telling us this program may not be ultra effective, because we still have a vast majority of people coming back into prison after being part of this program. Now let's take a look at percentage changes. So maybe we're interested in the effectiveness of the program over time, right? Is it helping decrease the recidivism rate over time, and by what percentage? And so what is the change in recidivism between time 1 and time 2, right? People who went through the program in time 1 versus people who went through the program in time 2. And so what we have here is we have the frequency of time 2 of people who recidivated minus the frequency of time 1 divided by time 1. And we divide by time 1 because time 1 is the baseline, right? We're comparing everything else to that baseline. And since that's our first time, that should be our baseline moving forward, right? So if we had a time 3, we should still compare that to time 1. And then we want to times this by 100 again to standardize that on the percentage scale. And so what this is telling us at the end of the day is that recidivism rates among participants decreased by 14.4%, right? And we have our little decrease here because our final number is a negative, right? It's negative 14.4. And so this tells us that our recidivism rates decrease over time. And so that's a positive thing for this program, right? Because this is telling us that as the program goes, or at least between these two time periods, we had a decrease in recidivism between the two time periods. So maybe the program's getting better. So again, when we're talking about ratios, rates, and percentage change, right, what we're doing is we're identifying different ways to present the data. And these are the most standard ways to present your data. So if you were to do a report, for example, you'll be using information like this to present your data to a stakeholder or a community organization, or some other stakeholder that you may be working with. Now let's talk about graphical representations of data. So in this case, we're typically talking about pie charts, bar charts, histograms, and line charts. There are other types of graphical representations that we're not going to get into. If you're interested in some of those other ones, talk to me. SPSS, Excel, and other statistics programs have options for other types of charts, but these are the most commonly used in statistics, and particularly for presenting your data to a public audience. So what are each of these? So a pie chart, most of us should be familiar with most of these. I think people get confused between bar charts and histograms, and I'll talk about those quickly. So a pie chart displays frequency percentages as a slice displayed within the whole pie, right? So the percentage of X group is displayed as a slice of pie within the larger pie. Right, so this gives us general proportions of each group within that larger pie. Bar charts are kind of like pie charts, except they display frequency percentages as horizontal bars, right? So bars that go up, and so the higher or the bigger your bar, the more proportion or the more frequency you have in that particular category. And again, pie charts and bar charts are both generally used with nominal and ordinal data, and that is because, especially for pie charts, you need to have a 100%. They don't work without having a total of 100%. And so the difference between bar charts and histograms is the type of data that you use them for. Histograms are almost identical to bar charts, but instead of using them with nominal and ordinal data, you will use them with interval and ratio data, right? And so the difference here is that in bar charts, the bars don't touch, and that is to identify the distinct categories of the different groups. In histograms, the bars touch because you're identifying that the categories are next to each other, right? So we're talking about something like a year, where 2005 and 2006 touch right next to each other. And you'll see what I'm talking about when we move forward. Line charts are similar to bar charts, but again, they're used like histograms with interval and ratio data. And it uses the midpoint, something like a mean or a median, and then connects a line across the dots. And again, I'll show you what each of these are. So let's go down to our different charts. As you can see, pie charts and bar charts are on the top, line charts and histograms, it's a histogram on the bottom. And again, pie charts, bar charts are used for nominal and ordinal data, whereas line charts and histograms are used for interval ratio data. So let's just take a little example here. Say we're interested in the race of participants in the prison rehabilitation program. So this is our frequency table, right? We have 6 Asian individuals, 76 Black or African Americans, 75 Latinos, 12 multiracial individuals, 54 white individuals, and 11 other. And so what we can do is we can take this information, and it gives us the percentages of each of these groups in a pie chart, right? So if we move over to a pie chart, what we can see is based on that raw data, or those frequency datas, we see that the largest proportion of people in the prison rehabilitation program are Latinos at 33%, followed by Black or African Americans, 24% white, and then it gets smaller and smaller from there. right? So this is a way to show the proportions or the slices of pie for each of these groups. And we can use the same data and move over and present a bar chart, right? And so instead of giving us percentages here, it gives us the actual raw numbers. Now, the nice thing about bar charts is that you can change them to do percentages, or you can change them to do the wrong number. So just for an example's sake, I chose the wrong number, right? And we can see the different proportions here based on the size of the bars. Now these can be interesting because they can be a little deceiving depending on how much you zoom into or out of these bars, right? So I can make this 75 look gigantic compared to the 67 if I just zoomed in really close, right? And we've actually seen that on television shows and news places where it's a sort of misrepresentation of the data. So it's important to be careful with how you scale your bar charts and your histograms. Okay, so as you can see, it's just two different ways to present the same data, right? Bar charts versus pie charts, two different ways to present the same data. So now let's look at something slightly different. Let's look at an interval ratio variable, right? So we're interested in the average days of participation in program by year, right? So we take all the people who are in the program every single year, and we calculate the average days of participation, or the mean of participation by year, right? So in 2005, people participated on an average of 12.4 years, 2006, 13.2, so on and so forth, right? So now what we can do is we can use histograms and line charts to see how those have changed over time. So if we take a look at this line chart here, as we see, program participation was comparatively lower in the first 3 years, and then kind of zipped up a little bit in 2008, and stayed fairly stable in 2008, 9, and 10. Right. So this shows us that there were changes over time in the average program stay or program participation. Right. So line charts are nice to show, especially when you're talking comparisons over time, how those comparisons how those numbers compare to the other years, right? So these are really nice to use when we're doing something like a time series design, or something where we're measuring something over time, right? So that way we can compare across time. Another thing, for example, if you're interested in doing this yourself, right, you can do this for your own weight if you're trying to lose or gain weight, right? And then histograms, right, same sort of idea, but instead of presenting this as lines, we're presenting it as bars, right? It's the same information, except we're showing it in the form of bars. And again, as you can see, the bars are touching, and that's to represent the fact that 2005 and 2006 butt up right next to each other, right? They're touching in terms of time. And so again, these are useful when we're using interval ratio data. They're also useful when we're looking at things over time, right? And so again, line charts, histograms are really nice to represent data visually when we're using interval ratio data. And so that's your introduction to graphical representations using pie charts, bar charts, histograms, and line charts. And we are at the end of our presentation today, so hopefully by the end of this, you should understand how to construct a frequency table, how to calculate percentages and proportions based on those frequency tables, and how to calculate ratios, rates, and percentages, as well as how to, at least at the minimum, interpret the graphical representations, pie charts, bar charts, so on and so forth. And we'll get, later in the course, we'll get into how to use programs such as SPSS and Excel to actually build those graphical representations. So this has been your basic introduction to descriptive statistics, or your basic descriptives. And this has been your daily dose of statistics.